Welcome. Think of the next few minutes as a workout for your brain. We're going to tackle some classic brain teasers that are designed to really flex those logical muscles. The ones you use for everything from planning your day to solving big problems at work.
So how about we put that to the test? I'm going to challenge you right now. Let's see how your brain handles a pure logic problem when you're put on the spot. Ready?
Okay, here's the plan. We've got 4 different puzzles lined up for you, and each one is going to target a slightly different part of your analytical mind. We'll start with a good warm-up and kind of ramp things up from there. Let's dive in. All right, first up is an absolute classic of pure deduction. It's all about 3 boxes of paper, but of course there's a twist.
So picture this. You've got 3 boxes in front of you. The labels say white, blue, and assorted. But here's the kicker, and this is the key to the whole thing. You know for an absolute fact that every single one of those labels is wrong.
So, your mission is to figure out what's actually in all 3 boxes. Here's the catch. You only get to open one box and pull out just one single sheet of paper. This is a great time to pause and really think. Which box gives you the most bang for your buck? Okay, you ready for this? The secret is to open the box labeled assorted. Now, why that one? Well, because we know for sure the label is wrong, so it can't have assorted paper in it. That means it has to be either all white or all blue. So the second you reach in and pull out, say, a white sheet, boom, you've just solved that box. And from that one single fact, the rest of the puzzle just falls like dominoes.
And that's just a perfect example of deduction, isn't it? As soon as we knew the assorted box was really the white paper, we also knew the box labeled white couldn't have white paper, so it had to have the blue. And that just leaves one possibility. The box labeled blue must be the one with the assorted paper. Simple, clean, and totally logical. So that first puzzle was all about pure deduction. Now we're going to add another layer. For this next one, you need relational logic. It's not just about facts, it's about mapping out how different people connect to each other. Here's the scene. 3 guys, Mark, Jay, and Fred, are going to a dance. Each one has invited the sister of one of the other guys. Our job is to figure out who's dancing with who, using just these 3 clues. This is one of those puzzles where grabbing a pen and paper is probably a really good idea. You got to figure out who's related to whom before you can figure out who's dancing with whom. So go ahead and hit pause if you want to give it a shot on your own. Okay, let's walk through this. The most powerful clue, the one that unlocks everything, is number 3. Marion is Jay's sister. Bam, we've got our first sibling pair. Now look at clue 2. Sally is not Mark's sister. Well, if she's not Mark's sister and she's not Jay's sister, she has to be Fred's sister. That's pair number 2. And by elimination, that means Joan must be Mark's sister. See? Now we know all the siblings. The last little piece is that Sally isn't going with Joan's brother, and we just figured out that's Mark. From there, everything else just clicks right into place.
And there you have it. Mark is with Marion, Fred is with Joan, and Jay is with Sally. Every guy is with someone else's sister, and all the rules are followed. Nice work.
All right, puzzle number 3. We're going to shift gears again. This time, we're moving from pure logic into a bit of mathematical reasoning. And for this one, a really simple equation is going to be our best friend. Now, I know this might look like one of those word problems from school, but stick with me. A customer spends exactly $20. Roses are $3 each, and carnation bunches are $2. The key is to turn this story into a simple math equation. 3 times R plus 2 times C equals 20. R is our number of roses, C is our number of carnation bunches. So now that we have this equation, we don't have to just guess randomly, right? We can be methodical. We know you can't buy half a rose, so R has to be a whole number. That means we can just plug in different values for C, the carnation bunches, and see which ones give us a nice, clean, whole number for R. And what's really interesting here is that, unlike our other puzzles, this one doesn't just have one single answer. It turns out there are 4 totally different combinations of flowers that the customer could have bought for exactly $20. Okay, time for our last one, our grand finale. This is a number puzzle that, at first glance, looks really, really hard. But it has this beautifully simple, elegant solution that's just hiding under the surface. So take a look at these rules. We need one number, the smallest one, that fits all of these conditions. I mean, where would you even start? You could just start testing numbers? 1, 2, 3? No way. That would take forever. There has to be a smarter way to do this. It really feels like it's just a brute force problem, doesn't it? Like you're supposed to just start plugging in numbers until you find one that works. It's kind of designed to look intimidating. But this is a logic puzzle, not a math test. And like all the best puzzles, there's a hidden relationship, a really simple pattern that connects all these clues together. And here it is, the pattern hiding in plain sight. Check this out. A remainder of 1 when divided by 2, that means it's just 1 short of being a multiple of 2. A remainder of 2 when divided by 3, it's 1 short of a multiple of 3. It's the same for every single one. Our mystery number is always just 1 shy of being a multiple of the divisor. So, if we just add 1 to our number, it would suddenly be perfectly divisible by 2, 3, 4, and 5. Well, that completely changes the problem, doesn't it? Now all we have to do is find the smallest number that 2, 3, 4, and 5 all go into evenly. That's called the least common multiple, and in this case, it's 60. And since we know our original number was 1 less than that, we just subtract 1 from 60. And we get our answer, 59. So much more elegant than just guessing, right? So let's just step back and look at what we did. We didn't just solve some puzzles. We've actually practiced 4 really powerful ways to think. We used pure deduction with the boxes, we mapped out relationships for the dance, we used systematic algebra with the flowers, and we found a hidden pattern to crack that number puzzle. And the really cool part is this isn't just about fun brain teasers. This is a real-world toolkit. You can use these techniques anywhere, at work, at school, just in your daily life. So the next time you're stuck on a tricky problem, think back to these. Which tool will you try first?